Hi, Assalamualaikum and a very good day to Sir Saiful Nazmi bin Muhammad. Okay, my name is Nur Najmina Ala binti Muhammad Yusof and my teammates are Ahmad Luman bin Zulkifli and Nur Ali Amira binti Azra Izzuddin. We are from Group 1. Today we are going to explain to you about experiment 1, that is vector. Okay, the objective of this experiment is to determine the weight of an object by constructing a vector diagram of the focus acting on the object. The apparatus that we need to do the experiment is Newton's scale, strings, board and paper, protractor, ruler, slotted weight 8 times 10 gram, 5 times 50 gram, weight holder 10 gram and pointers. These are the schematic diagram of the experiment. And this is a setup figure for the experiment. Okay, these are the procedures to do the experiment. First, as in figure 1, the apparatus was set up and make sure both Newton scale was set to 0 Newton. The second step is the holder for the 10 gram weight was hung from the knot. The third step, the center of protector was placed behind the knot. Step 4, the pointers was placed behind the string to record the angle as in figure 1. Step 5, tabulate the result obtained in table 1 after determining the force of each string. Lastly, increase the mass by adding 10 gram, 50 gram, 100 gram, 150 gram slotted weight to the weight holder. Repeat step 4 and step 5. This is result and data analysis. Okay, this is vector diagram for 10 gram. This is vector diagram for 50 gram. This is vector diagram for 100 gram. And lastly, this is vector diagram for 150 gram. Okay. I'm going to pass to Luqman to explain to you how to determine the weight from the base on the vector diagram. Luqman?
Okay, thank you, Najmina. To find weight from the base on the vector diagram, first thing first, you must to know and use the equation c to power of 2 equal to a to power of 2 plus b to power of 2 minus ab cos c. For your information, cos c is opposite with the line C, and then you must to know and find angle cos C, which is the balance angle at second quadrant and the balance angle at the third quadrant. To find the balance angle at the quadrant 2, you must use the right angle 90 degree and minus the angle which is value has been given. Alright, next to find the balance angle at the quadrant, first of all, you must to know the balance angle at quadrant 1 is same with the angle of cos C at quadrant 3, and you will get the angle of cos C, and then you can simplify this equation, forget the value of C or the weight. Alright, the next equation is compare each of the calculate weight vector diagram with the actual weight. Compute the percentage discrepancy. Right, to determine the percentage error for this experiment, first thing first, you must to know, you must to remind this question: percentage error, modulus experimental weight minus theoretical weight, divided the theoretical weight, and you must to time with the 100%, and you can find the weight percentage error. And you must to first thing first, you must to convert the value in gram to Newton because the experimental weight is in Newton, and then you can simplify this question, and you can get the percentage error of for this experiment. All right, I pass the Alia to continue the presentation.
Thank you, Lukman, for the explanation. So we are at the end of the presentation. So I'm going to continue with the discussion. During our laboratory experiment, the vector addition of forces was studied. A vector quantity is defined as a quantity with both of magnitude and direction. Both of these characteristics were taken into consideration when adding them together, giving us our vector sum. We demonstrated the process of the addition of several vectors to form a resultant vector experimentally, graphically, and algebraically. So at the end of the experiment, from the 10 gram mass, the weight is 0.092 Newton and the percentage error is 8%. Next, for the mass of 50 gram, the weight is 0.375 Newton and the percentage error is 25%. Besides, for 100 gram, the weight is 0.080 Newton and the percentage error is 19.2%. Then, for 150 gram, the weight is 1.431 Newton and the final percentage error is 4.6%. So, due to the result, we found that percentage error for mass 50 gram is higher than others. This is because there were a few errors while we do this experiment. We assume that there is a human error like error of reading the scale, which means we read the scale from one side, only not from above. So to overcome this, we need to make sure that our eyes are perpendicular to the reading scale. So the conclusion for the experiment is, in this lab, the objective of the experiment is to determine the weight of an object by constructing a vector diagram of the forces acting on the object. So, we learn how to add vector by their component and also graphically with the head to the tail method. This experiment proved that force has direction and a resultant force consists several vector forces. As a conclusion, we can tell that we were able to see how mass can affect the magnitude and direction of a force. Thank you.
That's all from us. Thank you.